So chapter 9, there's a quote from Isaac Asimov. Beginning students of chemistry often think of the science as a mere collection of disconnected data to be memorized by brute force. Not at all. Just look at it properly and everything hangs together and makes sense. Anybody have any comments on that statement? It's okay if you don't. There are some subjects that you can get through by memorizing stuff. I've never taken anatomy, but I imagine that it's mostly memorization. You gotta memorize what things are, where they are, what they do, right? In chemistry, there's a fair amount of memorizing, but there's also a cohesive relationship between most of the things that we have to memorize, and there's things behind them that we can understand. And oftentimes that does not come to you in your first chemistry class. I sort of had a light bulb moment the first time I taught a chemistry class, because I've been through graduate school, I've been through bachelor's degree in chemistry and taken all these different chemistry courses, and now I'm coming back and looking at the beginning stuff again. And I'm taking notes on the book because I didn't know what else to do to make a lecture. And it just kept hitting me. Oh, that's what that meant. Oh, that's how it works. And it was actually pretty exciting because everything was coming together. And so, if I was having that experience after earning a master's degree, I don't necessarily expect you guys to have that experience as a first-year chemistry student. But I'd like you to know that it's there. It's not just a set of random facts. It all works together. And if you can try to step back and see the whole picture, it really is quite beautiful. So with that blurb, let's get on to talking about periodic properties of the elements. I skipped 9.1. If I remember correctly, it has to do with transfer of different ions across cell membranes. Really, really interesting stuff, but go and read it. I'm not going to test you on it, so I'm not going to lecture on it. I just don't have time. So, Dmitri Mendeleev lived back in the 1800s for the most part. He put the elements known at the time in order by atomic mass and saw a repeating pattern of properties. This led to the periodic law. When the elements are arranged in order of increasing atomic mass, certain properties recur periodically. Now, Mendeleev was not the only one who did this. And in the text, it mentions some of the other ideas and other people. But Mendeleev tends to get most of the credit for it. He used the properties he observed to predict the properties of undiscovered elements. And there were a couple of places where ordering things by mass didn't fit his pattern, and so he followed the other properties and put the elements out of mass order. An example of this is tellurium and iodine. You find these on the lower corner of the periodic table. Tellurium has a mass of 127.6 and iodine is 126.9. And so by mass order, you should put iodine first. But by properties, Mendeleev put iodine second. So just an example of some of Mendeleev's predictions. He predicted that gallium would be discovered, and he predicted the properties. He predicted the atomic mass. He was pretty close. He predicted the density. He was right on. Formula of oxide, formula of the chloride. He predicted the discovery of germanium, and again was very close in the predictions of atomic mass, density, and formulas of oxides and chlorides. Predictions based just on properties he observed in the periodic table. So the periodic law is a law, right? It just predicts what happens. Statement of what we observe. It doesn't explain why that works. Quantum mechanics is the theory that explains why the periodic trends exist. When we know why something happens, it allows us to predict what will happen in the future.